Oh, sorry, it's over.
That's right. When we have Justin on, we put him to work even before the show.
I was doing it live. I was,
That's right.
The first demo of the day.
There was just a little delay. That's why he was still, you know, actively.
You're lagging. Yeah.
Yeah.
It's totally.
Everything's fine.
Well, guess what, everyone? Guess who's back on the show? We have Justin.
Me? Oh, Justin. Yeah, that's right.
Wave both hands.
And we have Adam.
Say hi, hey. Adam. Yeah, I'm here too. Hey.
And we have Adam's mustache.
That's right. That's right. He needs his own Twitter handle.
Twitter handle bars.
Is that? Oh, nice. Oh,
so
yeah.
Good. So good. I can't even come up with that level of gold. Well done, Justin.
Oh, I'm just watching our Twitch viewers just dropped after that joke. It's all right.
Is it the joke or the mustache? I don't know.
Can't follow that up. It's fine. We're segue to the next thing. It's good.
I'm speechless. I'm like, oh my gosh, where did they go? Well, they probably heard that we were going to talk about DNS, and they're like, DNS? People still use that? Is that still even a thing?
Databases today.
Oh, nice.
Running Kubernetes databases. This is how you do it.
You want the most robust performance database, use DNS.
Globally, scalable, key value store, eventually consistent. This is all good things. We're going to put some stuff there and make it work. And Route 53, 100% uptime. So you can't get a better database.
That's hard to beat.
I completely agree. I mean, it is phenomenal. So yeah, absolutely.
I do feel like we need like a disclaimer at the bottom. We're joking. Please do not run this as a database. Just so it's not used against us in some future reference.
Yeah, that's fair. But I mean, people it's not completely unheard of, I guess. But yes, it is mostly a joke. So, by the way, before we really get into it, we should mention that we have Container Day coming up. So day 0 of KubeCon, AWS is going to be hosting Container Day all day live on Twitch, twitch.tv/AWS. And then also here on our YouTube channel, for anyone that's watching us on our YouTube channel, youtube.com/containersfromthecouch. So feel free to sign up at this URL, and you'll be admitted freely, 0 cost to join. We're going to do the whole thing live. We're going to have all kinds of great talks lined up. We're gonna have some big reveals. We're going to make some announcements and have some how-tos, and we may even have a cocktail stuff. It's going to be fun. So we're going to do all kinds of stuff. You don't want to miss out. So definitely join us and sign up at AWS Container Day k8s.splashthat.com.
Pacific time zone. Just pointing that out.
No, it's actually Boston.
Oh, that's right. No, yeah, we're doing it Boston time zone. That's right.
Yeah, because it was supposed to be in Boston, and so we're like gonna keep the Boston feel. So I think we're gonna even in the middle of it take a tour of Boston. So Boston, yay!
I like that. I've never been there, so that sounds great.
You've never been to Boston?
I've never been to Boston. One day.
All right. Yeah, we need to make that happen. I know how you feel about flying though. So that's about the worst case scenario, staying in country. I think you're probably closer to Hawaii than you are to Boston.
It's like the same amount of time, and Hawaii is really nice and tropical. So I tend to choose that over. But Boston's cool. One day for everyone from Boston. One day I will be there. I really would love to check it out.
It's pretty great.
But what are we talking about today?
Well, databases for one.
That's it. It's all databases all day. We're DBAs today, so
that's right.
And really, I mean, yeah. So the External DNS is a Kubernetes project, and it allows you to. Kubernetes has DNS internal core DNS, It's how you do service discovery inside the cluster. But sometimes not everything's inside the cluster. So how do you get to things that aren't necessarily inside your cluster is really the goal of external DNS, is just syncing some sort of state of something internally and making that some friendly name externally to access.
Could you give a quick example?
No. I can give a lot of examples through the demos today, but I don't know about quick. I mean, it's really just about some external DNS service you have. We're going to use Route 53 today, but you can also use on-prem if you have DNS on-prem and you're running Kubernetes.
Okay.
Core DNS, you can run it inside the Kubernetes cluster. You can also run it externally, so you can have core DNS in your on-prem infrastructure, and external DNS interfaces with that as well. So you could say, oh, I have on-prem services. I don't need an external, external from my on-prem environment's DNS service. So you want something local. If you're running core DNS, there's a handful of other services you can use. And external DNS can sync internal Kubernetes resources, something like a service or an ingress or something like that, and sync it out externally to whatever DNS you want. So in our case, we'll be using Route 53. If you're running in Amazon, it's a great way to do it. Go ahead and sync some service, and we'll actually combine a couple things too, because the last time I was on, we went over the load balancer controller. And so we'll be using that to give us load balancers, and then using external DNS to give us some friendly names.
That's perfect, because when I used external DNS in the past, the use case was I had built, a service, and it was I had Ingress, and people wanted to be able to get to it, and I was talking to humans, right? And so, A35B, 37 more characters, for a load balancer name, I sent that link originally, and I said, oh, just bookmark it. You're always going to go to it. It's not going to change. Just keep it bookmarked. You'll be fine. And eventually they were like, no, we want a real name, a human friendly name that we could, easily say to our coworker, and they would know how to get to it. And so external DNS, that was my answer, and it worked beautifully.
Maybe you just need better humans to interface with that would remember those things. I don't know. That's one option.
So, we talk about pets versus cattle, and I feel like DNS names might be the last bastion for pets, right? Because you want them to have like a particular name, and you need to be able to remember them, and you like some names more than you like others, and so on and so forth. Whereas I was treating it in my scenario very much like cattle, where it's like, who cares what it is? Here's the link that'll get you where you want to go, and you don't even have to know what it is. You can just save it. And no, that wasn't good enough. So
I have this, the closer you get to the human computer interface, the more friendly it needs to be for the human, right? I mean, that's like, laptops are not cattle in that sense. They're not house plants. I don't throw away my laptop. Like I, define a lot of config, and like if it dies, like I'm going to be down for a little while, and I'm not just going to replace it with config management. Like there's no amount of config management that I'm going to do to my laptop that's just going to make it so like, I'll just throw this computer away. I think Chrome OS kind of gets there, where it's just like, hey, most of your stuff does sync somewhere else, but that's still like that doesn't. It's only throwaway because all of your state is stored somewhere else, right? Like all of my config syncs between these things, and so it's really just a matter of where is that state stored. And in a lot of cases, like if you don't have backups on your laptop, guess what? Like you're gonna have a bad day. And so it really is that the closer you get to the human, the more friendly and the more custom, and the more like you have to control that thing, and it's not just like throwaway names.
You're totally right, and I am probably less that way than everyone that I work around, and so because of that, I had to come up with using external DNS. What do you think? Should we dive into it? Let's kick this couch out of the way.
Yeah, that sounds good.
Let's get down to it.
I'm still waiting to get that couch someday.
Me too.
So I have a couple examples here that I want to show off. I actually want to see if my did my namespace is still terminating. There's a bug somewhere here that this isn't going to terminate for me correctly, but we're going to work through this.
Okay.
So we'll figure it out as we go. But the first thing I want to show off is I have a Kubernetes cluster here. It's in US West 2. It's on my demo account. We have one thing that I already set up was get pods. You can see I already have I can't select in that window. Nope, that's not gonna let me either. There you go. I have the load balancer controller already running. So I have, if I create, this is the new load balancer. So if I create ingress rules or services with annotations, that load balancer controller is going to automatically give me a load balancer in AWS. Nice. We set that up. We did this on the last stream. Permissions, everything else, how to do that is all set up there. So you can check that out. Wanted to show off the External DNS repo has examples for different environments, tutorials. So the AWS one is here. I am actually going to submit a pull request to this in a little bit because they talk about you do need some IAM permissions for this controller to be able to access AWS resources, right? Like anytime I'm going to say, hey, inside of some compute or Kubernetes cluster, if I want to call the AWS APIs, I need some sort of IAM permissions on it. They give a couple examples. That's a sample for what you need, basically. You can go more fine grained. So you can say, oh, this controller only does a specific hosted zone, a specific domain. This is a really generic, hey, if you want to control whatever with this controller, this is some permissions you can give. And they show you how to actually do this, sync this into, for the pod with kube to IAM and KIM. These are fine. They're going to give permissions at a much more broader sense, and you're going to have to run another controller. Inside of EKS, we have pod-based IAM permissions now. And actually, when I was walking through this last week, I realized that there was no updated documentation on how to do it with just only the pod has the permissions to the service role, or the service account inside of Kubernetes. So we'll show that real fast too, just how to set up the service accounts to just this pod. So no other pods on that instance can talk to DNS still. This is only for the external DNS pod. And then there's some other things we'll walk through here on just basically how to make the deployments, a couple settings we might want to change and considerations when setting this up.
Cool.
So switch back over here. Oh, not what I wanted. First thing I want to look at is if I go into get service accounts, you can see I have one here already set up for external DNS. And we have documentation on how to create service accounts. If I do it with EKS control, create IAM service accounts. Basically, I created this allow external DNS updates policy, and then the EKS control is just going to create that service account for me inside of the cluster. So it's going to give me that tie between an IAM policy and something that runs inside of the cluster. And I can get
one of those things EKS control does, just eliminating a lot of the heavy lifting.
Yep.
Love that tool.
And I can actually look at the service account here, and basically the main thing it's doing here is giving me this annotation on what role I want to use. So anytime I tell a pod, hey, you're going to use the service account named external DNS, I think is what I called it. It's going to mount in a secret that allows it to access the AWS API from that secret. Only that pod or any pods that are using that can do that, can access that API, which is good for security. It's minimum, only the pod has access, or only the containers inside that pod have access. You can safeguard these with RBAC inside of the cluster. So it is native to Kubernetes to say, hey, not every namespace can mount this service accounts. Only certain things can actually access it, which is great. So what I do in my my file here is external DNS demo. I actually say right here, service account name, external DNS. So that's where that's all I had to change in the example, essentially, of, hey, how is the example set up doing IAM permissions and with kube to IAM or something else versus how do we do it natively with service accounts inside of Kubernetes. So that's the only annotation I had to change. And a couple other things a couple other things to look at here is just some settings I'm setting on the external DNS controller. And again, what is a controller? How does this work? It's a software control loop that tries to take desired states and current state, and it's my little wooden box here of, hey, I need something set. As soon as I get data that says do one thing or do another, it goes and calls those APIs and does that. And so that's all this external DNS does. It's a controller. It's looking at state. And the main thing that it's going to do is I say two sources here. I want to look for services and I want to look for ingress. And that's where it's going to look in Kubernetes objects and say, hey, is there a service or an ingress with a specific annotation or something that I want to act on? And then what do I apply that to? And in this case, we're going to set the hosted zone I have here and this DNS name that I have for demo.jgar.net. And it's going to say, okay, I'm going to take whatever that service is and apply it over here to this demo.jgar.net. And then there's a few other things you can set in here about your provider, like we talked about earlier. You can have core DNS or whatever internally. One thing that is a little important and actually super helpful is there's a policy for the external DNS, how you want it to make changes. Do you want it to delete DNS records when the service is gone or the load balancer is gone? Or do you want those to stay? Do you want it to only create new things? Do you want it only to update things? There's a couple different policies here that external DNS can do, which is super handy, especially in large environments where you say, hey, someone accidentally deleted some service. It's not going to like completely hose all of your DNS too necessarily. You can set that on the controller itself.
And for clarification, nice. Upsert, I've only ever run into this actually when talking about databases, but basically it's a function that allows to either insert or update, but that's it. You can't delete, you can't do anything else. So it looks like with this policy, you'd be able to create something that's missing, or you'd be able to update a record that already exists.
Yep, and I believe the three defaults are actually. Let me just. I can get it, can't I? Here's the container that we're using. I'm just going to do a -- help on it. I believe upsert was defaults, so we can look at policy. So default is sync. So sync is going to at the very top of the page there is going to make the external DNS provider the same as whatever is inside the Kubernetes cluster. Upsert will, like you said, create things and update their settings, but it won't delete them. Whereas sync will delete. And then create only is, it's not going to change anything once it's created. So I can create new records, but once it's there, it's not going to make any changes to it. So those are really handy to have inside of something that as critical as DNS. However you want to manage it, we have a couple options here.
Nice. That's cool.
So the other thing we need to do is actually give some RBAC permissions to this controller inside the cluster. Again, the service account gives the container access to AWS things. RBAC gives it access internal. And so we need both those pieces of this puzzle here. And really, we're just making a cluster role. This is defaults from the walkthrough again. We tell it what it can watch, what it can do on those endpoints. So services, endpoints, and pods, what it can do to ingresses. And then we just bind that here to the actual service account here.
Nice. And that's a lot of just read level access, yep. Right? Get, watch, and list. So nothing dangerous there.
It's not doing anything internal to the cluster that are making changes. It's only going to make changes externally. But yeah, this allows it to get access to those APIs to read.
Cool.
So
we had a question. I think it's just clarifying, but Mariel 1980 asks, Route 53 is a way to reroute network traffic. Where is Kubernetes related to that? And maybe I can clarify. Route 53 is Amazon's DNS service, and it's used in this particular demo and example as the way we're going to present a friendly name to the services that we're running on Kubernetes. So normally when you run a service on Kubernetes, be it using an Ingress controller or just a service type, you get a load balancer name, but it's not human friendly. So we're gonna basically layer on a human friendly name.
Oh, that's not So while you were saying that, I deployed basically those two files of a deployment and RBAC, and just checking out the logs for the controller itself, showing that, hey, we're all set to go. I don't have any permissions errors right here. It sees that everything that it should be creating is already up to date. So the controller is sitting in the wait and see state essentially until we create the two things that we wanted for ingress and services.
Perfect.
So the very first thing we'll do with that is look at the service that I want to make. And this service, typically services inside of a cluster, you don't necessarily need to give them a load balancer. They don't need to be externally routable. Obviously, in this case, we do want it to be externally routable. And so we're going to, based on, excuse me, this annotation of external DNS, we're going to give it a host name based on that hosted zone that we told the controller it can act on, Nginx demo. So it's going to make another subdomain under that DNS entry. And so it'll actually create this for me in Route 53. And I think that's it. I thought I had one other thing. I'll look for it. But yeah, that's the only change I make. This is just create Nginx, basically.
So this is a service object, not an ingress. Yeah.
Services can, oops, did I spell apply right? Services can get load balancers, but it's not necessarily, it's not an ingress.
Yeah.
And some of the differences there for people, ingresses are only HTTP. Services can be TCP or HTTP, which is good and bad, depending on what you want to do. Ingress has a lot more filtering functionality. By default, our ALB or our load balancer controller will create an ALB, not an ELB. So application load balancer versus an elastic load balancer gives you a lot more insights into the application traffic itself. HTTP layer 7, it's going to say, oh, what host name am I routing to? That sort of stuff is going to be really beneficial. So I already have my load balancer here. Let me see if I can copy and paste this in a different window. Nope. Because I don't want to. Some of these take a little while to provision too. So we'll let that go in the background. But also we can see, if I look at my logs again, we can see I did an upsert here for that nginx.demo JGAR. So it's going to create that entry. So if I look over at Route 53, look at my hosted zone, get rid of this, make it a little bigger for you.
Awesome.
Right here. So I have the A record for Nginx demo. So the controller already made that. Even if the load balancer is not actually ready to serve traffic, external DNS is fine, just saying, hey, I know this endpoint that I'm going to send this to. And actually, we can look at this a little bit more.
I also noticed it was smart enough to make it an alias, like an Amazon Route 53 alias, not a CNAME DNS alias.
And so if I look at it here, you can see that it's pointed to the load balancer endpoint that I have here, and once that's provisioned, and there you go, there's Nginx. So there's the load balancer endpoints. And if I also go to Nginx, if I can spell right, Nginx demo, I get the same thing. It's still, both are routing to the same ALB. Load balancer controller made the load balancer endpoint, and the friendly name was made by external DNS based on that annotation that I gave the service. Which is
very
great.
Cool.
That's like what we want, right? Like, hey, now I get a friendly name automatically for the service based on this one endpoint. I'm actually thinking I changed the. No, I didn't. I had a demo for this as well, where you can do this with an NLB as well, and I can give a friendly. You can't give a DNS name to it because it's not going to route. NLBs are going to be layer 4, and so how am I going to route traffic to that? I can still actually make a DNS entry for a network load balancer, but we'll skip that demo for now because I don't want to recreate what I did. I think all I had to do was change an annotation, but I'll probably fumble on it and won't get to the other parts that I think are also handy. So we'll show those.
Cool. Yeah.
The other one I'll do is actually get. I don't know why my 2488 is still terminating. So let's just recreate. Let's change the.
I was totally hoping that you were going to deploy the 2048 app.
I will.
The last time you did that, I just want you to know I spent the good second half of my day playing 2048 thanks to you.
You're welcome. We're just going to call it new because I don't know why. New. So we're going to create a new 2048 namespace. This deployment is going to be in that namespace. And we want the service in that namespace. Call it new. And then in this case, we're going to create an ingress for that service. So here, again, we have different layers of it where I have a service inside of Kubernetes and I have an ingress pointed to that service. The last Nginx, we skipped that ingress piece and we just pointed the load balancer directly to the service. In this case, we know it's application load balancer. We know it's a web application. So we want some more control over that. So we're telling the load balancer controller, we want an ALB, this ingress class here. And we're telling it it should be internet facing, essentially. So that's really all we need to do. And we don't need an annotation for our host name because Ingress, because it's layer 7, automatically has the concept of what a host name is. So in this case, we're going to call it 2048 demo jgar.net. So the external DNS controller knows I need to look at that endpoint and I need to take action on that. I don't need something else to tell it what to do. Oops. Let's write those changes. So like I said, it just made that new namespace deployment service ingress. So get all in, what we call it, 2048 new.
Yep.
I got 5 pods behind it. I got my node port service, my deployments, my replica sets, and I already got my my load balancer endpoint coming up. I saw a question pop up, but I didn't read it.
Exceed 0 says you don't need path/star if you only have one rule for your backend.
Correct.
Which, very true. Yes. However, it's very conceivable if you're using Ingress, probably going to have more than just one rule for your backend, because that's the beauty of Ingress, is that you can share.
So I got my load balancer. Let's see if it's up yet. Nope, not provisioned quite yet.
Did we see the Route 53 record? Did you show us that?
No, I was going to go over that. So let's refresh here. It's already there.
Oh, sorry, that comment is still on. There we go.
So it sees, like I said, the same endpoint here with whatever ALB I wanted. And so once it's ready, here's my 2048 at that hosted zone, which is exactly what I want. Should be up pretty soon. Oh, let's actually look at one more thing. The logs of the entry.
We're not seeing your terminal.
Oops, you're right. I am. Oh, it's what's your problem? Didn't get it yet. So one thing on the external DNS, excuse me, is it by default has a cycle of 1 minute pulls, mainly for API limits in Route 53. And so there is a situation where if you're looking at a lot of zones and you want them to update faster, or if you want to do multiple hosted zones, you probably need to run multiple controllers is kind of the recommended way to do it. If you lump a lot of your DNS hosted zone controllers into one external DNS, when you want to make a change to one of them, you're going to take down someone else. And so based on how your team looks or what it looks like internal to your environments, it's probably recommended to run multiple controllers. But be careful of those API limits. You can make the polling higher just to say, hey, you know what, like a 5-minute pull is probably fine, or whatever the case. Just be careful of that if you're going to hit those limits.
Now, back in the day when we ran at web scale, at my previous companies, we would actually insert records into multiple DNS providers, because that way we could avoid, being affected by a DDoS at one provider. It looks like, and based on what you were just saying, it sounds like external DNS might be able to help me with that. I could actually sync my records to Route 53 plus other DNS providers like Dyn, or I can't think of the other ones off the top of my head.
If I look at project, they have a whole list of what they support, which is a pretty extensive list for where here's all of the DNS providers.
There we go.
Send it to. So yeah, for sure you can do a lot of things here with whichever, if you want Cloudflare, and if you can even do Route 53 and CloudMap, right? Like CloudMap is internal AWS for like service discovery for other things. So if I want to say allow Lambda to call out to one of my internal Kubernetes services, I don't necessarily need to go outside to a load balancer like that's externally facing. I can do that through CloudMap internally, and it can show my service names internal to AWS, so the Lambda can call that. It'll find that through CloudMap and then route over to my service in Kubernetes.
That's a really cool feature, actually. I hadn't thought about Lambda, and imagine like Lambda inside your VPC where your Kubernetes cluster is running. That could be a way for it to be able to, effectively discover your services.
Yeah, that was one of the demos I was trying to show here, and I ran out of time. So, but yeah, there are a lot of opportunities. Yeah, let me see if this is up.
Boke Joe mentions it's so nice to have the automatic DNS record upsert. Forgetting the dots at the end can cost you some hours and headache. Yes, totally.
For sure. One other thing, also, it's interesting. The newer external DNS has the option of basically tagging your records so that it knows which ones it created, and it won't just go through and, like, if you have a subdomain but some things are managed by something else, by Terraform or even a manual process, and external DNS, it's not going to go through if you have sync turned on and necessarily delete everything in that subdomain. So it made it a lot safer to use external DNS inside of a larger environment where not everything's in Kubernetes or managed through a certain way.
That's really good. Yeah, I've definitely had sync where like two things that had sync would, effectively erase and create each other's records. DNS does not like that.
Right. You're going to have two automation fighting itself.
Yeah.
Let me see what's going on here. Let's see if we can find 48. Got my node ports. That's all I needed there. Got my ingress.
And that ALB, has it even come up yet?
Nope. I should just check inside the console too. Where it's at. It says it's active. Did I miss something? No?
No, you got that.
Oh, you know what? I bet. Let's go back to the terminal. I think I may have messed something up when I changed those names. Double check here. Namespace. Here's my deployment and my app 2048. Did I change? I'm thinking I changed one of the match labels to 2048 service. There you are. No, service name is 2048. Where's my labels? Selector. No, 2048 still. So that's my ingress object. And obviously I got, that's right. That's my
labels.
No, but that's my app is still 2048.
Yeah.
And
I think you found it.
And my service is service 2048. So that's what I'm routing to. Let's see. Unchanged, unenables. I think it might be parsing that as a number.
Mm.
There we go. So that shows Ingress was configured, but everything else was unchanged. Interesting. Let's see here. Get.
I mean, we saw the service was set up correctly, so.
Why do I keep typing 7? Okay, let's. I don't want to kill too much time on this. We'll check back on it. But actually, we'll try one more demo too, see if it comes through for us. So the other thing I actually wanted to show off was an actual real world use case of like when this is going to be even more helpful. And for me, the first thing that I thought of was like, hey, you know what everyone always wants? You want a PR based endpoint. Like I want to test some code based on a PR and just say like, hey, give me a friendly name, give me a load balancer, make this the thing that like is easy for me. And so typically how people are going to do this is based on some bot or a Jenkins job or something, like someone's going to manually go in and tweak a bunch of stuff. What I did is and you can do this with any templating that you can do Helm charts. You can do. I'm going to use an event substitute. I just flashed on the stream. I hope we're okay.
Yeah,
you did. I was wondering if the beeping in the back, the construction work, they cut your fiber and we lost you, but you're back.
Is the beep loud? I hear them down the street, but I don't know. Okay.
It's faint.
Okay. So what I want to do here is I'm going to make basically template out this application for every PR I get. And I can do this through a script. I don't necessarily need 5 replicas, but the only 2 environment variables I want are what environment am I sending this to, and what's the get SHA for that endpoint. And so it's going to recreate everything and just append those 2 things to it, and also give me a host name based on that. So I have, based on my environments, based on my get SHA, I should get an endpoint for whatever this rule is inside the environment.
And you may have said this when you were frozen. What are you using as the templating engine?
Event substitute is just a bash command that basically will take an environment variable and spit it out how it should look with the variables rendered. And so if I do get SHA, there, handy command here for what is the short SHA of my Git environments. So I can now echo SHA, and that's whatever my Git commit is there. And then I'll just manually export env equals PR. So this is a PR environment. So I just dynamically get these as I go through.
And PR is pull request.
Pull request. Yeah.
That's what we're after here.
Yep. And then if I look at this external DNS deployments, I just created one. Again, we have 2 controllers, one for my official demo stuff, and then one for my PRs based on this repo. The main differences that I changed here, still looking at services in Ingress, I changed my policy to sync. So I will delete things when the resources get deleted inside of Kubernetes because I don't want them sticking around. And now I have a different domain filter for pr.jgar.net. So my template is just going to look a little bit different now. So I can deploy that. We're reusing the same RBAC that we had for the other controller. There's no reason to create 2 RBACs here because they need the same read access. I can see it's already up and running. I have a demo and a PR controller. Let's just double check it. Okay, so we're all set to go. We get that same service token that we used in the first case to talk to AWS resources. And it's just saying, okay, we're all set to go. And so what I want to do now is using that template file that I created. Again, you can put these wherever you want inside of your CI/CD. You can put them in Jenkins, whatever it is that you want. This is basically my pipeline here, where I'm going to cat that template file, which has those variables in it, and I'm piping it to event substitute. By default, it's just going to go straight to standard out, so we can check it and say, okay, here's my rendered hostname now. Oops, wrong window. So I should get a host now based on this. It's going to replicate everything inside the Kubernetes cluster. This is, oh, you know what? No, yeah. This is taking, whatever code, however you're doing this in CI/CD, and it's just replicating the entire thing into the environments. And one cool thing about this, which wasn't the case with the old load balancer, is you're going to actually, it's not going to cost you much more money, because with the new load balancer controller, I have a group. So I have a load balancer, one load balancer with all of the service names behind it. So all of the ingress rules that have different host names can still be used on this same ALB. So it's not, if I have 20 PRs open, I'm not like burning money, like, oh no, like my manager says I need to cut down on the ALB. It's like, no, like we can group those together and then we can hit them based on DNS. It knows about host names and it'll route it to the right namespace, the right service inside of the cluster.
That's awesome.
So the only thing I need to do here is apply and read from standard in. So literally it's just going to take it. We'll see it creates that namespace. It creates the app. It creates a service, and it's going to create the ingress. All inside of this namespace here. Oops. I forgot I can't copy and paste in that window. Okay, so everything's already there. I already got my deployment. I got my service. I got my target group. So inside of the new load balancer controller, it names the load balancers that are part of a target group slightly different. If I look at it here, my first one here is just called Kate's 2048 new. That was the namespace, and 2048 ingress basically. That's probably really small still. Let's get a little bigger. Go away. If I refresh here, we see it's provisioning this new Kate's 2048 PRs. So this is going to give me all of the PRs are going to be behind this load balancer once it's ready. And I hope this one actually will work for me a little sooner.
That is so awesome, and it's so easy to just drop that into your CI pipeline and just have it,
And it's so flexible because, again, if you're using Helm charts, if you're whatever it is you're using, you can send a flag for, hey, I want you, instead of having this host name, you're just gonna have a slightly different host name. And using the load balancer controller and using external DNS, I'll automatically get those things. I should probably already have my, I got my hosted zones. I have the other one for PRs. And you see I have this AC98 already ready to go once the load balancer is up. And so all I have to do is, again, if I go back to terminal, let's get two of them.
Yeah, so as a developer, you would know your Git SHA, and you would just be able to figure out the pattern.
Right. And again, these variables are arbitrary. Git SHA is a good way to know that the PR is kind of unique, but if you wanted even a more friendly name, you could do it. So all I had to do is change that one variable and apply again, and I'm going to get a 2048 PR hello endpoints, and I don't need to provision a new load balancer. All I'm doing is external DNS is going to say, hey, where's that load balancer endpoint? So if I look at logs, here we can see it created the first one. That's where it created it. And then in a minute or so, when it pulls again, it'll create this new hello endpoint. Come on, baby, get it to me. I still feel like I have something wrong in here. I kept messing with it on Friday because I was changing too many things and not tracking my progress. And I was like, oh, I want to show this too. Oh, I want to show this. And then I was like, oh, it's only an hour stream. So I was trying to be careful.
Well, seeing it in the logs is certainly validation.
Right. Okay. So I have the active endpoint here. So the load balancer is provisioned. And then if I look at,
I always go view edit rules and then click to get into the target groups from there and see that I have targets in the target groups. There's probably like a more direct way to do it.
Where do you go?
On the screen you're on, view edit rules near the bottom in the center.
Man, I'm not saying this though. View edit rules. There you are.
And then from here,
here's my two. There's one PR. There's my new hello one that I created.
Yeah, so you see how then forward to, and those are clickable. Those are each of your target groups. So I usually find those and then look to see, do I have targets in the target groups?
I do.
And they're healthy.
Those are the two endpoints in the cluster.
Oh, but you're doing instance-based, not IP-based.
Right. Yeah, because these are Kubernetes is exposing them.
Okay, that's fair.
Did I get any of them? That's not there.
I think I do IP-based because of the VPC networking.
It's routing now. Let's see.
Yeah.
Yes,
if
I do have
VPC networking. That would be the case.
And I can see that the port, like the pod picks a random port, so it found it there. So the 3069 is the port that's whatever pod is running on that node. So Kube proxy is exposing that for me.
Mm-hmm.
But yeah, why is it not getting it for me just yet? Here's my new one too, because this is all set up. Again, it's going to be a different port. Oh, did I set up? I may have messed up my security groups on Friday.
That'll do it.
That might be where it's at.
Yeah, like check one of those instances for the security group rules.
Yeah. By the way, I do this all the time too, is you have the working solution, but then you keep going and you didn't commit it.
I was going to show up here if I looked at the logs for
Oops.
the PR endpoint. I did get that hello PR already. So both those endpoints, as we see in the console, are showing up. They should be healthy. Where is my instances? Oops. Unclick. There we go. Always super exciting to watch people walk through the.
It's a good way to learn.
Yep. Security groups for that instance, and these should all be shared because it's the same for EKS control created the cluster for me. And it's
are these attached to the load balancer?
Click edit inbound rules. That view for me is a little bit friendlier. So these are all like the source is another security group or the same security group. Yeah. There's nothing that's like external. So you'd have to look for what security group is your
load balancer.
ALB and make sure that
I work backwards from that. And so I can look at this Kate's ELB 2048 new 2048 PRs. Here we go. So that's the ALB inbound from everywhere.
Select that security group ID OBD 247 needs to be in your list of security group rules for your instance.
OBD's right there.
So the second line there, and it's all TCP.
Yep.
Okay, may not be a security group problem.
Where else should we try? I feel like this is so close, and I want it to work.
And we're sure it hasn't started working.
Nope.
While we've been. Okay.
Let's go back to. Oh my gosh! It did start working. It was DNS resolving. Look at that. I was just gonna go back here and say, what happens if I dig it?
DNS.
And I get my, yep, it was DNS replication. Woohoo! All right, so we got 9 minutes left, and we're just gonna play. So here we go.
Hey, we're still ahead of schedule. That's awesome.
And again, that was, so this is my hello endpoints. I don't even remember what the other endpoint was. I probably have the standard. Going to this ELB, I realized for the PR's endpoint, I don't have a host name associated to it. So it's not going to route me properly because it doesn't know where to send me because it's looking at the header for the host name. And so until
that's a good point.
Yeah. And so until I send it, for the PR endpoint, what host name I want you to actually route to, it doesn't have a default route. You can set up default routes, and I could say, okay, if someone hits this endpoint without a host name that you recognize, send it over here. But otherwise, I'd have to look at what my other ingress is.
So Bokcho asked, can you flush the cache from Route 53? And no, but I do think like similar question would be, what TTL does the record get set with? So if we look at Route 53, there's an A record pointing to the load balancer DNS name. But if we then look at the load balancer DNS name, here we go. Yeah, custom TTL.
And you can set that as an annotation on the record itself. So I could say per service or per ingress, I want a TTL of whatever for this service. And the controller will do that for you on the endpoint as well.
Yeah, but it's probably worth pointing out, since we're talking Route 53 specifically, and it's setting a Route 53 alias, not a CNAME. I've never actually needed to customize a TTL with that. It seems like every time you update something, it gets the update very, very quickly. So you may not need that if that's your particular scenario, but if you're talking to a different DNS provider, then yeah, TTL might definitely be worth exploring.
Yep.
HRawZinko223 also got TTL while we were talking about it, and then says we also use Ingress Controller plus external DNS. Do you have a sense? Actually, go ahead.
Yeah, Ingress Controller is a way that a lot of people have been doing this to basically share that load balancer. It was the same thing that now the new load balancer controller allows you to share it. The old Ingress Controller would, Nginx runs inside your cluster, creates one external load balancer. And so all of your services are bound to Nginx inside the cluster and not something externally. Only Nginx talks externally there. And so that's absolutely a way a lot of people do that. And it works great. It's a way to cut down on some of that cost. You get the headers for routing by host name. All that stuff still works. External DNS can still sync that, pointing it to Nginx essentially. The only difference here is by using the external load balancer, we get a couple of benefits out of, especially if you're using like an NLB. There's a couple of different settings you might need to do for like, if you want to preserve the IP address of who sent you the request, because you're talking, the external load balancer is sending it directly to the port endpoints on the nodes rather than routing through Nginx and then going to pods. So you do save one hop there, but it's up to you and your environment how you want to run it. Nginx and other Ingress controllers have a lot of other features depending on what you want to do. In this case, if you want to share a load balancer, and grouping could be based on PRs, could be based on teams, could be based on namespace, whatever you want to do. Sometimes running multiple Ingress controllers inside the cluster gets a little bit tricky depending on, hey, some stepping over someone else's ingress and that sort of stuff hasn't been the best inside of Kubernetes for larger scales. And so doing that directly to load balancers with load balancer controllers in a lot of cases makes sense to scale it to a more complex environment.
Nice. That's awesome. All right. So just quick recap. We deployed a service. We used Ingress, the new Ingress controller, and then we created friendly names for our services using external DNS.
And
pretty
dynamically
great
with PRs. Yeah.
It's just the dynamic PR thing is that's so cool. So cool.
It's a great use case, great example.
Yeah. So if you have questions about this, reach out over Twitter. You see all of our Twitter handles here. Definitely give us a follow. Also, I want to throw out one more reminder: sign up for Container Day coming up. If you're at all interested in Kubernetes, you're all interested in containers on AWS, then definitely give us a sign up there, and you'll have an entire day for free to attend our container conference the day before KubeCon.
Come to KubeCon too. It's gonna be great.
And come to KubeCon. Yeah, absolutely. All right. Anything else?
I think we're
That's
good.
a wrap.
Cool. All right. Check you guys tomorrow.